So we're asked to find all possible values of inverse sine of a half using two different approaches. The first one is to write sine z equals a half, write z equals x plus iy, and then look at our formula sheet and look what sine z is if z is x plus iy. This generally should be quite a quick method because this is pure real rather than a mixture of real and imaginary parts. So looking at our formula sheet, we've got sine x cos y, so we have 1/2 is equal to sine x cos y plus I cos x sine y. So we normally we take real and imaginary parts. We normally look at the part which is 0 first. So we have cos x sine y equals 0. So we sort of know that we expect to get a real answer to this because sine z equals a half. Well, we know what the answer is, but just to be absolutely sure, and as an exercise, let's see what happens if we say, well, we're going to choose to make cos x 0 and see what happens. So if cos x is 0, that implies that x is equal to n plus a half pi. Now, if x is equal to n plus a half pi, that basically means that sine, where n is a feature, that basically means that sine x is going to be plus or minus 1, and that can't happen because when we take the real part of this, we've got a half equals plus or minus cos y. Y is real. It's impossible. There's no cos y has a minimum value of 1, so it can't possibly be minus a half or plus a half. So we know this is impossible. So this would imply that a half is equal to plus or minus cos y, which is impossible. So this is, we can rule out that possibility. So cos x can't be 0, so this means that sine y is 0, and the only real solution to that is y equals 0. So we know for sure that the only solutions to this are when x is real. When z is real. So we already know these solutions. Y equals 0, which means cos y is 1. We've already said this is 0, so we just get the result sine x equals a half, and we know very well what the solutions to that are. X is, just to remind you, sine looks like this. This is 2 pi and this is pi. The solutions are here and here. So this is pi by 6. And this is pi minus pi by 6, which is 5 pi by 6. So it's either pi by 6 plus 2 pi n or 5 pi by 6 plus 2 pi n. So that's one way of doing it. The other way of doing it is to use the general expression, the general formula for inverse sine of z, which is this expression here. So yes, we just plug in the values. So therefore we get inverse sine of a half is equal to minus I log. Then we've got I over 2 plus, then this is 3/4 square rooted. It's root 3 over 2. Now, one thing to watch out for is when you see this raised to the power 1/2, just remember that implies a plus or minus sign. So we've got two solutions here really. I'll now put those two solutions in. So we've got I over 2 plus or minus root 3, because when you take this, the square root of this, obviously there's going to be two solutions to the square root. So don't forget the minus here. If you didn't put the minus here, you only get one set of solutions, and then you should realize from part A that you're missing something. Okay, so that's yes, so that's, you want log of that. Then next we need to actually write this in polar form. So we have to draw a few diagrams. So these complex numbers. So the plus one, it's root 3 over 2 along the x, and it's 1/2 upwards. Okay, so this is root 3 over 2 plus I over 2. And the other one is just this with a minus sign, so it's the same height but in the other direction. So that's the other one. Okay, so basic trigonometry, hopefully you realize this is a half. Well, the next thing to say is the modulus of this. So the modulus of this is squaring this. It's 3/4 plus squaring this plus 1/4. So the modulus of this is 1. So if this length, if this line here is 1, this is a right angled triangle, and this is a half, hopefully you know this is going to be pi by 6. This is also going to be pi by 6, which means the argument of the first one with the plus sign is pi by 6. The argument of the second one, the minus sign, is 5 pi by 6. So we've got two answers here. We've got minus I log of e to the I pi by 6 plus 2 pi n, or minus I log e to the I 5 pi by 6 plus 2 pi n. So when we take logs of this, we end up with, bring down the I, minus I times I is plus, so we end up with pi by 6 plus 2 pi n, or in this case, taking logs of this, bring all this down, multiply by minus I, we get plus 5 pi by 6 plus 2 pi n. So you can see probably part B is a more complicated method. In this case, anyway.